equipment. We supplied the exchanger and the pop-off valves. There's 4 of them. Where's the other one? 1, 2, 3, 4. There's another one somewhere over there. Oh, 4. Okay, the sludge is coming in on the bottom over here, going through the exchanger, through the different tubes, and it's coming out here. Okay. The water's coming in here, going through the exchanger, coming out here. They're counterflow. In other words, sludge is going one way, the water's going the other way. If they both went the same way, it wouldn't exchange heat. So
maybe that's our problem over there.
You got a problem on one? No. So anyway, it's sludge in, sludge out. This would be water in, or water out, in, and water out. So they're counterflow. What they do is the sludge is going through a 6-inch tube, and the water is going through an 8-inch tube. So you got a tube surrounded by another tube. The water jacket is the outside one. So the sludge is going around, and the water's going the opposite way, following that pipe around, beating the sludge uniformly through the whole thing. These pop-off valves are set for 50 pounds. I don't recommend that you try them. In other words, test them. As I was telling him a story about one that I told the guys don't test them because sludge has fine particles of sludge that if it don't reseat, you're in deep trouble unless you know where to turn it off. Well, this guy did it. It was in a basement. He didn't know where to turn it off. By the time they found out where to turn it off, they had anywhere from 3 to 6 inches of sludge on the whole basement floor, and the drains weren't hooked up. So don't test these. Just leave them. They're set to pop off at 50 pounds. In the shop, we test this thing at double the pressure. It's been tested at 100 pounds. Anyway, the sludge goes in, and you'll see on the end the castings. It goes from one casting, then maybe down through the next pipe, through the next one, then it goes over through that set, and it just keeps working around until it gets back out to here. Same way with the water, only it comes in and out at counterflow, and it does the same thing. You can take, let's say your heat exchanger cakes up, and you can tell by the gauges your in and out temperatures are the same. You're not getting any exchange. That's usually a sign that your tubes are plugged up. You build up a film on them. You feed it the sludge with no water going through it, or in other words, you had sludge into the exchanger, water going through it, but the sludge wasn't flowing. In other words, you turned off the sludge pump. And you can build up, you can cake to the side of the tubes. If that happens, you can pull off the end bells on both ends and still leave the water in. The water's on the inside bell. So you can pull out the outside bells and rod those tubes and still leave the water in the exchanger. You don't have to drain the exchanger. If you wanted to drain the exchanger completely, there's a plug on the bottom of this one, and there's a plug on the bottom of this one that you can take out. If you do ever take them out, you might as well put valves in them. We don't put valves anymore because they keep getting broke off, so we gave it up. If you guys got a question as I'm going along, just stop me.
Could you point out the plugs you're talking about?
Well, they're way in the bottom.
Okay.
You'd have to get on your hands and knees.
Okay, okay.
Well, this one's right here.
Okay.
And the other one's right under here.
Okay.
The only time you would use those if you wanted to drain the exchanger completely. And if you do drain it completely, I would put it back with valves. Okay, the exchanger, this one here, there's a valve to bleed the air or in the water. You would open it up and it'll bleed the water. The other one over,
bleed the air.
Huh?
Does it bleed the water or bleed the air?
Bleeds the air. But you're going to get till you get
out of the water,
out of the water.
Out of the line.
The other one bleeds the air out of the sludge, but I guarantee you, if you open that one up, you better have a hose on it, because you're going to get a bath. This one you can open anytime you want. It'll just bubble the water out. But that one there, you never know which way it's going to shoot, unless you stood back here. And
well, you got to be careful. It's hot water too, though.
Right, but you're only going to crack it, and it'll just bubble out easy. When you initially fill it, you need to have these open so they don't get airbound. The sludge and the water and the sludge. Heat exchanger does not get airbound, but every once in a while it does. Maybe over a period of a year you might want to come and open this, just crack it, get a little bit of air. If you're not getting sludge flow, that transfer again, I would put a hose on that one and open it up and see if it gets airbound. We had, well, I've been doing this for 17 years, and in that period I know of 2 that have gotten airbound. And one guy did his sludge, he read it in digital, I mean intense, and that's how close he wanted to keep it. And it dropped a few tenths on him, and it was airbound. That's all he did is open up the air vents, let the air out. So this one's water, and that one's sludge. I don't know where you're going to drain it to, though.
Yeah, I was noticing that myself.
You know, I looked around, I didn't see, you know, I don't know what's in that pit over there, but you're going to have some kind of place to drain it. Okay, you understand the in and out and the counterflow?
These are 50 psi also, for the water?
Yeah, they're all 50 psi.
Even the water side?
Right, well, all 4 of them, and on the other 4 too. Like I say, this was tested at 100. Okay, the gauges, there's sludge in, sludge out, water in, water out. And the gauges have a capillary tube, which is right here. This would be sludge in, sludge out, water in or out. Let's see, I get them mixed up myself. Water in and water out. Now, gauge is within a half a degree. If you have to ever change the gauge, or, well, if you have to change the gauge, the capillary tube has to go with it because you can't cut it. You can't take the capillary tube off because it's filled with the gas. If you do this, the secret of this thing is to tie a little string on it when you pull it through here. So when you get the other one, you can tie a string on it and re-pull it through. The gauges are, you can adjust these by taking this plastic cover off, just popping it off, taking a screwdriver and getting in the middle, hold the needle, and go the opposite way you want to go. If you want to lower the temperature, you would turn it to the raise side. If you want to raise it, you would turn it to the lower side. But you got to hold that needle to do it.
And why do we want to adjust that?
I don't know, but I just know they're adjustable.
But they're set from the factory.
Right, they're yeah, from the factory we buy them from, and they're within a half a degree, so I don't know why you ever would, but they are adjustable. So you just you can pop this glass off the front, get a screwdriver, small screwdriver, hold the needle and turn it the opposite way if you want to raise or lower. There is no moving parts except for the flow of the sludge in the water. Let's go around the end.
What's the temperature range of this thing? The maximum temperature?
Well, there is no maximum temperature, but they tell you, which we kind of found out.
Say for instance, if I want to run this hot water loop at 230 degrees.
You're going to be in trouble.
Okay, so there is a set thing. That's what I'm trying to get at.
We say in our book from 155 to 160, but we found out now that we've gone to thermophilic, you guys know what that is, they go to 180.
Yeah, that's cool. Yeah.
And there's no problem with baking a sludge at 180, 85, somewhere in there. But the one thing you want to remember is if you don't have a sludge flow going through this thing, you don't want to be running hot water through it. In other words, if you turn off your sludge flow, the sludge that's in here is going to stay.
It's gonna bake.
Right. But if you don't turn off that water flow, it's just going to send that 100 and whatever degree water you use, let's say 55, through there, and it's going to bake that sludge to the side of the tubes. So one thing you never want to do is to run the hot water without a sludge flow.
Yeah, it's happened to us already.
Well, how'd you clean them?
Huh?
How did you clean the tubes?
We had to
Take
take
the
everything,
end
take the caps
end
off.
caps off.
Yeah, then what'd you do? Use a wire brush?
Rod.
Oh, just water?
Yeah,
No, rod.
A rod?
Yeah, we
With a
have to
brush
put-
on it?
Yeah.
Yeah, it's a dirty
Yeah,
job.
yeah, it was.
And the worst part, you can't take this one off, you know, so you just got to do it from the backside and hope you get it all.
The bottom one's the hard part.
But normally this will be
Through it? Yeah.
We're gonna try it, yeah. We're shooting for sludge temperature like 127 or something like
Yeah.
that ultimately.
So you're going to be doing
Hemophilic,
thermophilic.
yeah.
Thermophilic,
Yeah.
so this one's going to be it's going to have water and sludge all the time then.
Right, right. It'd be
gonna
very
go
unusual. But yeah, we'll have to talk to Sammy and see what kind of alarm systems we have, because that'd be good to have that tied in, that, you know, to trigger a reminder, you know, that if you
There's
lose
no
a hot
water
water
or
pump,
anything
shut
like
that
that?
sludge pump off. Yeah,
There's no way to tie the two together.
there is a way. Yeah, if we can monitor the status of these motors on the system, we'll link it up
Yeah.
to do that. Because
Isolation,
I'm glad you
get that
mentioned
valve
that.
Yeah,
See that valve should have
that's
Hate-
that's the only fallacy of the tube in the tube.
If you have to shut the sludge feed off on the system, you got to shut the hot water.
Oh, yeah. No, this
Get it? What's the problem we had last
this bottom one here is sludge in.
Sludge in.
Okay, this one.
Okay.
This one here is sludge out.
So we're talking about the temperature.
It'll all be labeled by the time you guys get it.
This is water in,
Okay.
and this is water
Water
out.
out.
So they're going against each other.
Okay.
You can turn that off for a minute. It's going to go to this tube, and then in the front you'll probably see it crosses over to this tube, and then probably up to this tube and back and forth. But you can take these off and still leave these on, and the water will stay in it. If you have a leak in one of these, they'll be independent. The water cannot get into the sludge, and the sludge cannot get into the water, vice versa. So, you guys bought extra gaskets. The 6-inch will go on this one, and of course the 8-inch on the back one. The best thing, if you do have a leak, there's weep holes in here, so when you originally start it, you're going to get a little bit of condensation out of it. Don't worry about it. But if it persists, then you got a leak. The best thing to do is, if you do have to take these out, is back flush them with water, or flush them with water. Especially out here, you got no drains or anything. It's better just have water. Huh?
They just call it Vector.
So that's about it. Unless you guys got any questions.
I had a question for operations. Are these heat exchangers just
Yes.
for this digester, or is it everything?
Or is it both of them?
Both of these are for that digester.
Okay, for this one. Oh,
Yeah.
okay. So not only number 2, not number 1.
Both digesters.
Oh, for both digesters.
No, just for number 2.
Just for number 2.
I thought number 1's just a pond with a
Oh, wait a
mixer.
minute. If these two are for this one, what do you do? Run it through this one, then run it through this one? Is that how they do it? I don't know.
I just build them.